Biggest Loser because they really hit home as to what I need to do today. I'm going to do our no, you just watch. It's really mathematical. Yeah, I'm sure right now. I need you to just pay attention right now. You want to talk to me about something. So we got this Biggest Loser Theorem, right? Real mathematical sounding, right? Of course it is. Of course it is.
About weight, yeah.
About weight. Okay, so what I'm going to do is put W of T up here and T down here. So this is like my time and weeks, and that's going to be my weight in pounds. Okay? Everybody okay so far?
Yes.
So I have no Buffy's in here, right? No Buffy's, right? So Buffy's a contestant on The Biggest Loser. Buffy starts off at 453 pounds. That's why she got on the show, because she wasn't very healthy. She was, you know, about to be a diabetic, high blood pressure. So she wanted to lose some weight, and she got on the show so she could be healthier, lose some weight.
Are you sure she didn't want to be a sumo wrestler?
I'm sure. So 6 weeks later, she ends up weighing 300. Well, she really be doing some things. She was at 200. 362 pounds. So now I'm posing a question to you. And I need some discussion about it from you. Is there a time that Buffy absolutely, positively had to weigh exactly 400 pounds? Is there a time that Buffy absolutely, positively had to weigh 400 pounds?
Yes.
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 Everybody agree with that?
Yeah.
She had to be 400 pounds.
Yes.
Why?
You can't just skip a number.
You can't just skip a number, huh? You got to weigh something at all times.
Right.
Okay. Guess I didn't pull the wool over your eyes, because each time I do this, I have this conversation, and somebody says, But like at weekend the other day, a couple of weeks ago, she was like, well, she could be eating, and she could eat a lot, and then she started off, she weighed 453, but then she was eating a lot, and all of a sudden she weighed 450. I said, so you're trying to tell me she didn't make those weights in between? But you do have to hit every single weight in between, right? Because she has to weigh something at all times, which is what you're telling me, right? She always has to have a weight. Now, is it possible she weighed more than that?
Yes.
Is it guaranteed that she weighed more than that?
No.
Well, you said I was guaranteed the 400. Why am I not guaranteed that she weighs more than that? She had air. Okay. But she could have, right?
Yes. Because at one point she would, you know, she probably wasn't so dedicated to
Right,
the diet.
It's
And
that.
You know how they get to go home sometimes for about a week or so, or a few days? Excuse me. And she didn't follow her diet. It was hard for her at the beginning, but then she kicked in and started doing it.
Yeah, she realized she had to do something about it.
Okay. So, folks, you just did the Biggest Loser Theorem, but it's really called this.
Intermediate Value Theorem.
Okay. You just did the Intermediate Value Theorem. Now, you told me she had to weigh something at all times, right? So basically, W of T has to be a continuous function, right?
Yes.
Because she always has to have a weight, right?
Yes.
So it's continuous. Can we safely say it's continuous on our interval from 0 to 6 weeks?
Yes.
Because that's when we did the game show.
Yes.
Okay. Is it safe to say that the weight she started, the weight at time 0, is not the same as the weight at the end?
Yes.
What was the weight at time 0?
453.
What was the weight at time at the end? So those are not equal. So now I picked a number that was in between, right? Is it safe to say that the number I picked was in between? What number did I pick?
400.
It was in between. Which one was the smaller one? 362. So for mine, I have to put W of 6 first, right? Yeah. Even though the 6 looks bigger, W of 6 is 362, and it's smaller than what? W of 0. So is it safe to say that number is in between both of those?
Yes.
Everybody's okay so far?
Yes.
If that is the case, then did that weight have to happen sometime between 0 and 6 weeks?
Yes.
So basically, there is some time, T, right, on this interval from 0 to 6 weeks. Are y'all okay so far? You better wake up. Such that W of T was equal to what? 400. Does all of that make sense?
Yes.
Is there anyone confused about any little piece I just did? No. So my weight was a continuous function. My start and end values were not the same. The number I used was between the two y values, my two weight values. And so there had to be a time on that time interval that I started with that I came up with that 400 weight, right?
Okay, you keep asking us the same question in different words. Why?
Because we're going to look at note card number 7. See what's wrong with this?
7?
Note card number 7. Siete. Everybody at note card number 7?
Yes.
Not quite. Note card 7. Let's look at the Intermediate Value Theorem. It says, it's an existence theorem, right?
Yes.
Which says that a continuous function on some interval cannot skip values. Buffy could not skip a weight, could she? Otherwise, she just, I guess, disappeared for a brief moment and went to some other dimension, and then all of a sudden appeared. Well, that just doesn't happen.
No, even if she went over there.
She had a weight, didn't she?
Yeah.
But it would have been a different value than $20. It didn't hit that value. She went to the moon and lost them and came back.
But in the process of going, she had to gradually lose. She didn't all of a sudden just
See, at that
change.
way, there won't be a uniform for that kind of
As long as we stay here on Earth, though, let's look at what the Intermediate Value Theorem states. It says if these 3 conditions hold, what are the 3 conditions? First, your function must be continuous on some closed interval. Does that make sense?
Yes.
If we're talking about the Biggest Loser Theorem, she always had to have a weight. And she had to definitely have it on the time that the game show lasts from 0 to 6 weeks, right?
Yes.
Step 2, the y values at the beginning and the end cannot be the same. Her start weight was not the same as her end weight. Step 3, and this is where step 3 ends. K is some number between f of A and f of B. What was the K value I picked?
400.
400. Was it between the two y values I picked?
Yes.
Then, if these 3 conditions hold, I am guaranteed that there is at least one time or one number C within that interval such that f of C equals to K. If I do it based on Buffy, there's at least one time on the interval from 0 to 6 weeks such that f at that time is the c value, had to be 400. Why did I say it a bunch of different ways? Because I wanted you to relate it to this general math scenario. Intermediate value theorem. Think about what the word intermediate means. What does that word mean to you, intermediate?
And the lowest
Not so hard.
standard.
Not so easy, not so hard. It's usually like a level in the middle. You got beginner level, you got advanced, and intermediate is usually somewhere in between, right? So the intermediate values have to exist in between. The first, the low one, and the big one. That's what basically happened here. But that is only true if you have a continuous function. Because if my function wasn't continuous, I can introduce all kinds of craziness.
Continuous on the closed interval.
Continuous on that closed interval. The y values at the endpoints have to be different, because if they're the same, then if she started off at 343 pounds and she ended up at 343 pounds, who's to say she lost or gained anything? There's no guarantee is there.
What if it was
As long as those two numbers are different, she has to hit every weight in between. Does that make sense? And then finally, whatever value we're talking about, whatever k value, and k is a y value, that's a y value, that must be between the two y values at your endpoints, then you're guaranteed the c, and c is an x value.
I have a question.
Yes.
What if at one point it becomes like a parabola?
It could be a parabola. You're just saying I'm guaranteed that as long as I'm continuous. So you're saying that?
Yeah, like she started off on that same weight,
Uh-huh.
lost it and came back and just stayed on the same weight.
So that's what I'm saying.
Well, what's
Unless you see the picture,
There's no proof.
there's no proof that she lost weight. You're not guaranteed that she lost any of this weight. If you didn't see this picture, if all you knew was there was a continuous function that connected those two values. That's all you know. And
So if you got surgery, you can't say you lost weight.
let's stay with the program. Y'all are coming up with too many different scenarios. Let's just get the understanding. Okay. So anywho, what weight would you pick in between here? There's no weight that you're guaranteed to hit in between there, because you just picked the same number. So you've got to have all of those in place before you are guaranteed. See, yours is a possibility, it's not a guarantee. If the shape was a parabola, yeah, it could possibly happen. But if these y values are the same on the ends, I'm not guaranteed that that didn't happen. All right. Let's see how a problem may be given to us. Number one is very rarely given as an AP question. Okay. Number one is very rarely given as an AP question where they just blatantly state, use the intermediate value theorem. You're usually not going to use that phrase, intermediate value theorem. You typically have to recognize when it comes into play. That's why number one actually did not come from an AP test. You notice there's no asterisk, but we need to practice it. So it says, use the intermediate value theorem to show that this function has a 0 in this interval. Well, let's see. We got to go through our steps. What are our conditions? First, we need to make sure we can use the intermediate value theorem. What's condition 1?
Is it continuous?
All right. Now, what kind of function is this?
Parabola.
It is a cubic. It's not a parabola. More general than that, though, it's a polynomial. That is a polynomial, and all polynomials are continuous. All polynomials are continuous. I think I've said that before in here. Yes. Okay, I heard a no and a yes. So if it's continuous everywhere, it definitely has to be continuous on this interval from 0 to 1. What's the second condition we must check?
If f of a cannot equal f of b.
So what is f of a, and what is our a? 0. What is f of 0?
B. Can be 1.
No? Confuse me. What is f of 0, kiddos?
Maybe a y intercept.
I mean,
Y.
negative 1?
Negative 1. Thank you in the back. Negative 1. You are simply plugging a 0 in for the x is what is going on. F of 1. What is f of 1 equal to? 1 cubed.
1.
Minus 2 times 1.
2.
I'm sorry, plus 2 times 1. So what does that give me so far?
1.
It gives you 3.
3 minus 1. 2. Okay. Ooh, that was pulling teeth. That was pulling some teeth. So does step 2 check out?
Yes.
F of 0 does not equal to f of 1. What is step 3? It says k is in between f of a and f of b. Well, what is my k value? 0, because they asked me, did we have a 0? So k
No.
is equal to 0. Is 0 in between these?
Oh, yes.
Yes, it is. F of negative 1 is indeed less than 0, which is less than f of 1. Therefore, IVT applies. And we're going to apply it.
It should be F2, right?
I'm sorry, thank you. No, what did I just do?
I know, that's what confused me.
I'm sorry, that should have been f of 0, thank you.
Yes.
I apologize. Thank you, Mr. Eason.
You're welcome.
Okay, you're Mr. Eason today?
I'm his
There's the... You're his duty friend. All right, are we ready to make this apply? If you have your calculators out, take them out. Oh, that's so janky. Nobody brought it. No, we still have to do number 1. It says use the intermediate value theorem to show that there has a 0 there. So we're going to actually find where that 0 occurs. Alright, so I want to know when does this function equal to my k value? In this case, my k is 0. There are numerous ways to do this one. I typically like to put this one in either y1 and this one in f2, or I think on the Inspire this is f1 of x, right? Yeah. And this would be f2 of x. And I want you to look for the intersections. Yes?
Wait, I don't know how to put it in the calculator.
Oh, okay. This is what you wrote.
Wait. Let me try. Yes, it's in.
Let me know when you find the intersection. Okay. Maybe someone
Do you
take
want
it
to
on
plug
that
in
spot.
0?
Ooh, look at what I said. The left side you're going to put as your first function.
Okay.
The right side you're going to put in as your second function. And you graph it, you're going to locate the intersection.
So I'm saying,
Yes, I'm listening. I'm listening.
when we get you in the calculator, you want us to put 0?
No, I want you to put, see the left side where I have F1 below it?
Okay, I put that.
And then F2, did you put 0? That's what I want. That's why I put F2 below the...
That's what I'm saying. You want us to put
Okay,
0.
for F2, yes.
Yeah.
I thought you meant N for the X. We weren't on the same page. We're there now.
It's somewhere between 1.5 and...
You're going to actually let the calculator find the intersection for you. Calculate the intersection.
How do I do that?
Actually, I'm doing it now with Inspire so that I can help you. I can tell you right off the bat on my other one.
So we get a graphic here?
Graphic, yes. Excuse me. Pause the thing, because we're just wasting time. So we're going to